Hello and welcome to Capstone 2010 project. This is a brief description of some of the networking configurations that are in use for the project. What you have before you is Cisco Packet Tracer. It is a program developed by Cisco to enhance the learning of their students enrolled in the Cisco Academy courses. And it enables you to create simulated networks using routers, switches, PCs, servers, so on and so forth, and test systems before you actually put them into production. This scenario is a rough simulation of what we will have going on with the physical example that we're working on, and it mirrors the configuration that is present in the 3 classrooms at school. Over on the left hand side here, we're going to simulate the computers in room 450 by using 2 virtual PCs, well, excuse me, not virtual PCs, but 2 PCs that are only present here in this simulation software. They'll be represented by the 10 network. PCs 3 and 4 here represent the PCs in room 456 and will be on the 11 network, and PCs 5 and 6 are on the 12 network and represent the student PCs that are in room 943. This configuration is not exact. It is only similar to what we will end up displaying in the project, but basically we're using what's called a router on a stick configuration. This group of PCs, this group of PCs, and this group of PCs are all on different networks. They can't normally communicate with each other through this switch, but they can communicate with each other through the router. If PC 6 wants to speak to PC 2, it has to be directed by the router. These 2 lines only carry information for this network, these 2 lines for this network, and these 2 lines for this network. However, this one line to the router will carry all the information from any network, route it, send it back down, and then the switcher would disperse it to where it needs to go. The greatest challenge networking wise was addressing these computers. They're addressed via DHCP, which is Dynamic Host Configuration Protocol, in which a server will assign them an address when they fire up. They will request an address and then be given one. The problem is the manner in which a computer requests an address is not routed by routers. So if PC 6 were to be turned on right now and ask for an address, its packet would go up to the switch would route it to the router, but then the router would throw the packet away. So the DHCP server over here would never receive the request and subsequently never answer. We overcome this problem by telling the router to accept this type of packet and what to do with it. So the computer will request an address, the request will go to the router will send the request to the DHCP server. The DHCP server will choose an address out of a predefined pool that we established, and it will send it back to the router, which will in turn send it back to the computer. This configuration will also ensure that computers 5 and 6 receive addresses off the 12 network, 3 and 4 receive addresses off the 11 network, 1 and 2 receive addresses off the 10 network. And the actual prototype, the DHCP server, will actually be present in the 10 network as opposed to being out here by itself. Thanks, that's it.